नहीं, मीटिंग या वेबिनार में ऑप्शन ही नहीं आ रहा, मेरा ऑप्शन ही आ रहा, वेबिनार का ही ऑप्शन आ रहा है बार बार। हाँ, आ गया आ गया आ गया आ गया आ गया आ गया, हो गया। Good evening, everyone. Mhm.
Anji, good evening, sir.
Good evening, ma'am.
Anji, पहुंच के घर?
Yes, ma'am.
So quiz, you have received the quiz now from the resource person.
Yes, ma'am.
So Sanchit ji today, right?
Yes, yes.
And Saurabh Nandpal.
Hello,
Hello.
can you hear me?
Yeah, I can. I can see you also.
Hello.
Hello.
Hello, Sanjit ji. We can hear you. We can see you also.
Okay, can you hear me, sir? Hi, good evening,
Anji,
everyone. Sorry, I got late by a minute. My laptop got restarted, so it was taking time to reboot.
So Ajay sir, shall we start with the recap?
Actually, the person who's doing recap has not joined now.
Good evening, sir.
Are you there?
Yes, sir. Yes, sir. I am here.
Okay. Then you can do the recap of the first session of yesterday.
Yes, sir. Yes, sir.
Yeah.
If you could please share your webcam first.
Yeah, I'm also sharing my webcam actually.
So a humble request. It's a humble request to all the participants Whosoever is in a position to switch on the webcam, kindly do it.
Yeah, we
It will
can
be
have.
very helpful to us to send, for our participation report to AICTE. This is very helpful to us. Thank you very much for honoring the request.
Yes.
Even I am traveling today, so
Shall I start, sir?
Yeah,
Yeah.
sure.
Okay. So good evening, everyone. Good evening. So today I am going to conclude previous lecture. So recap of the previous lecture, which was provided by the Sanchit Singla sir, which is one of the alumni of our LPU University. So he has provided the insights on the cloud computing using the SaaS technology. So he has discussed about the basic concepts of the cloud computing, so which includes the various challenges faced by the SaaS via, like lack of the analytical governance and the difficult managing the portfolios of the diverse technologies. And one of the more challenges computational issues with the big data and the processes to pressure to provide the scalable solutions within the constrained budgets and the rising cloud costs. So managing the big data is one of the big concern that sir has discussed about, and how the big digital businesses want to automate their businesses, and with the help of this AI and the comprehensive data that has been provided. And the SaaS VR, which is one of the open platform for the AI and the analytics, which provide a flexible integrations across the AI and the analytical lifecycle. Sir has also talked about the SaaS architecture, which includes the engine, control system, and the supporting parts. And this engine is one of the most important piece of the SaaS. And this control system, it makes sure that the whole platform functions properly without any failure. And one of the two more components which are the main which are related to the SaaS architecture is include CAS, that is Cloud Analytics Services, which is distributed and in memory computing engines. And second is the microservices, which are self-contained and the lightweight platform components. Sir has also discussed about the Kubernetes, which is one of the open source system for the management, placement, scaling, and the routing of the containers, and most of the SaaS which are included in the containers. And there are a lot of benefits of using this Kubernetes, which are planet scale, unlimited growth is there, and which can use anywhere. So this was all about the previous session. Thank you, everyone.
Thank you, Kamal man. Two things I want to say. Well described and well attended also.
Thank you, sir.
Right, good attention to the details, as yesterday we all were there, and you really explained it very well.
Thank
Now,
you,
one
sir.
more thing I just want to ask all the participants who are there, all my colleagues, if you have any question related to yesterday's session, Sanchit sir, you can ask. Let us have 2-3 questions and answers from Sanchit sir. And please share your webcam while asking question. That's the condition. Is any questions, Jitendra ji? We can't hear you. Rathod Saab, any question? No questions?
No, sir. No, sir.
No questions. Okay. Mohit Saab, any question? Dr. Mohit?
Hello, sir. Good evening. No, sir. It's fine. Good evening, ma'am. Good evening, sir.
evening, sir.
Okay. So I think Sanjit sir, the things were your content was well taken by everyone, and now we can move forward with your presentation. So people are still joining; they will keep on joining, and right?
Yep.
People have joined, so you can start with your presentation. I hand over the platform to you now.
Okay, thank you. Thanks.
Before that, if you allow, just 1 minute webcam sharing with everyone. Navjot ma'am, Dr. Rahul Desai, Dr. Dhavinder Pathak. Just 1 minute webcam sharing. Dr. Mohit Arora, you are requested. And Mr. Hetal, and a lot of people are there. Neeraj, Vaishali, Dr. Rahul, Indu, Dr. Manjot. We can have a photograph with all of you. Right? Let us share our webcam. Neeraj ji has shared. Rana Dhruv, Navjot ma'am. Yeah. You see, there are some places where there is no cold. Means हम लोग को ठंडी लग रही है. There's people are in hot places also with t-shirts and all. Neeraj ji, are you staying in a place where there is no winter? I hope. And Ramaya ji also. Right. So let me see how many of us have really. I can see some people who have. We are enjoying no winter. We're enjoying spring. Right. Please switch on your webcams. मोहित सर विंटर के बारे में बोला, वेबकैम के बारे में नहीं. राणा जी, Navjot ma'am is also there. I'll just Princey. Okay, I'll just take one screenshot of this thing, and I'll post it on. I'll ask my colleague to post it. Right. Thank you very much. Sanchit sir can now take over and let's start the session.
Okay, thank you. And Kamaljeet ma'am, thanks as Ajay sir also mentioned. Thanks for a quick recap, which was quite illustrative. And so let me share my screen and let me know once you can see this. So can you see my screen?
Yes, we can see, sir. We can see your screen. It's quite visible.
Okay, sure. Thank you. So, and today I will be talking about why is there a need for a data and AI platform. So, in our yesterday's session, we talk about the platform, we talk about the cloud computing, we talk about the major components of a cloud-based architecture, which SaaS via compromises and which all challenges which it caters to. And today I will be talking about data part. So now the platform is ready. Now what all challenge the data with the data governance, with the data monitoring, with the data management, and how we cater these challenges using a cloud-based computing, using the high computation resources to manage this data, right? So 2025 top technology trends that we have is data and the AI governance, synthetic data, quantum AI, decision intelligence, applied machine learning and agentic AI, trustworthy generative AI, purpose-built models, AI augmented data, and AI development. So you might have, or you might be familiar with these topics because these are the generic terms that are being in trend in last year and for this year as well. Data and AI governance is one of the major highlight and synthetic data as well. Machine learning models, to develop the AI-based models, you need full data. Okay, you need plenty of data. You need billions of millions of record, because as much data you can provide to your model, the better your model will be trained. and it can give you the better responses. So you might have heard about ChatGPT, you might have heard about Copilot, you might have heard about OpenAI, and now there's a new company that had got that got appeared from China, which was, I guess, Eric or something. So they have trained their models, they have trained their structure, so that with lot of with excessive data, so that you can get the appropriate results. If, let's say, it through a Copilot, I'll write, okay, write me a letter, write me a note for a for anything, like for a sick leave, for anything, or try to generate some quiz questions for me with the correct answers. Simple example. So on a specific topic, it will give you tremendous replies from different trusted sources. It will give you the desired informations. But have you ever imagined how actually this is so accurate with what we have provided in a simple layman language, and how it is treating or reading those sentences and giving us the direct required information? This is all with the data that we feed to the system, and we have trained those models. So that's why I kept this topic of data and data governance with high performance computing session. Okay. Now, data and AI governance. Organizations use data and AI governance to manage and control their data assets and AI initiatives. Okay. 40% of enterprises will actively or proactively invest in AI governance for compliance. Regulatory compliance at the institute level, at the in the banks, or at the country level, is very hectic process. If I talk about India, there are a lot of regulatory compliance that banks have to meet, have to maintain with regards to the requirements raised by our central regulatory bank, which is RBI. Similarly, European banks have to maintain their regulatory compliance as per their European Banking Authority. We call it as EBA. Okay. Similarly, federal with regards to US and the other countries or other nations, right? So that's why this AI is into picture. You can maintain or create documents of your entire model development life cycle. What all data you are feeding, what is the trend in the data, what is whether those variables were categorical, whether those variables were, let's say, linear, what was the relation, everything goes through that report, and they need this level of information in their regulatory documents, right? So that's why all these channels are coming, all these artificial intelligence tools are coming that helps to maintain this all this regulatory compliance, because maintaining this regulatory compliance, generating those documents, is very expensive for any institute. They spend millions of euros every year on this regulatory compliance thing, right? So let's talk about the VIA capabilities with regards to management. Okay. So we talk about the data integration with the other databases like Teradata, Oracle, Hadoop, SAP HANA, any SQL database. Okay. So we got the connectors. SAS has the connectors to connect to those databases, and you get the holistic view, or you can read those tables directly into your SAS programs. Okay. the benefit that industries are getting, the benefit that developers are getting, the benefits that data management teams are getting is they get the seamless view of seamless integration mechanism between their databases, between their SaaS programs. They get the seamless experience within their program. So take an example like you have your web application, which is having a form and it is getting some entries like name and then age and then inquiry and then the submit button. On submitting a button, the information gets stored into a table. This table can be MySQL. If I talk about PHP-based application, when we use WAMP or LAMP, it can be Java. If it can be in any relational database like Oracle Teradata. If I'm submitting through the Java servlets or through REST APIs or through my JSP pages. So it can be anything. Now, this data gets stored into the database. The next part is how you can get this data to generate a trend, how you can get this data to get some meaningful information. So you need to have some programs where there should be a connectors, readily available connectors to read this information from the databases. Okay, so that's the data access or seamless data connectivity. Now, the next part is data preparation. Data preparation is for your model development. When I'm saying model development, where do we use these models? As I explained yesterday during my yesterday sessions, these models get used in deciding the business rules, like in deciding the business strategies, in generating the way we write a single statement on Copilot or let's say in Chat GPT, how those models, the backend models will respond to your queries. That all goes through the models. And to develop a model, we need the underlying data. We need the features. If let's say I'm saying if a person has 50,000 of salary in a month, has a family of 4 to serve, staying in a or living in a metropolitan city, going for a leisure travel once in a 6 months, going for movies or going or spending his lot of maximum portion of the salary in, let's say, in leisure activities like movies, in theme parks, that person may default. Okay, if I will grant loan to that person, because the ratio of expenses versus the income is quite low. And so how do I predict? That's the prediction, and this prediction happens based on my trend that I've observed in the past. So banks, if you might have seen that we have this UPI, we have the online monitoring, online payment systems, right? So entire data is captured within the banks, right? If they want to monitor, or if they want to develop some models, like whether I will sanction a loan, or will I give credit card to such persons, to such candidates or to such accounts who are spending their 70% of income in leisure activities, then this is a risk for my bank to for against such people, right? And if that person is spending 30 to 40% of his salary in basic expense, like the house rentals, the grocery, the medicines, basic day routine, then that person is reliable for a bank, and bank can offer and bank can offer the credit card or a loan to that customer. And if you know this experience, the CIBIL score, all these scores comes out based on these mechanisms. So to generate that scorecard, you need to prepare a data like number of transactions done by the accounts in last 6 months, average balance maintained by the customers in last 1 year. Okay, total fee amount paid by the customers every month. Okay, ratio of the transactions done over the weekday versus weekend, ratio of the transactions done, or the total amount of transactions done on the in the leisure activities like cinema, like theme parks, okay, the theater. So all these things are getting captured in the back end, and they are using this data to generate the trends. And that's why we in every sales in every Amazon big billion shopping days in Flipkart, we get different cards. Like you get SBI, you get ICICI, you get all these. So from where all these cards come into picture? Because they have this much data, and that's how they predict, okay, for this year we're gonna have this much sale. For this particular, let's say Diwali sale, or let's say the Navratri sale that's come around that time. So they do predict how much revenue we gonna get, and that's how they get all these things happen. So everything is through data. Okay, so next is data governance. So this is, again, you have the data into a platform, then how the will analyze what's the quality of the data, how many columns I have into those tables, but how many rows I got, and what is the information being captured, like how the significant the variable or the columns is. If let's say I got 20 columns and 19 columns are blank, if let's say the same value, then the data is not relevant for me, because what I will get out of that, if I will analyze the data, like nothing, because there is nothing to analyze. So the entire data is junk data. So there should be the governance platform. There should be some facilities, or there should be some out of the box available capabilities where you can govern your data, where you can analyze your data, but the underlying data of model development. Okay. Next is visualization. So drawing the data or reading the data through the tables is little bit tricky, right? So here you are getting in terms of the information, okay, like information catalog, but extending the data into the pictorial presentation, into the graphs, into the let's say the network charts or pie charts or bar charts. It can be vertical, it can be horizontal, it can be any type of exploration, right? So this gives me the clear understanding, if you see this graph, that my maximum, or my, I would say 60 to 70% population resides above average line, right? So if you see, we get political surveys, we get surveys through different channels, that we have our the poverty line is the population under the below poverty line is decreasing. So how are they deciding? So all these things get evaluated or gets encountered through all these visualizations. Next, cost-effective compute scaling. So SAS workload orchestration. If you remember, I was explaining about the cache controller and the worker nodes. So cache controller manages the worker nodes, and if let's say any worker node gets failed, the other worker node will automatically spin up and will resume the business. So that's on. This is on single server or multi-server deployment. So if we have people from the IT team, okay, who are, I would say, who are quite informative about the server architecture. So single server deployment, multi-server deployments, where we will have pool of servers on and several applications get deployed individually on those servers. Like one server will be dedicated for your data management. One server will be dedicated for your computing engine, where all the code will get executed. One server will be dedicated that is governing, that is doing your authorization and let's say mailing services and all. So to orchestrate those different in terms of the multi-server architecture, there has to be some mechanism which maintain a sync between these servers. So that's like scaling and orchestration. Okay, so all these things that SaaS address or this VIA platform addresses, and these are the biggest basic requirements if I am running high computing servers, or I'm getting or I'm executing the big data on or queries on the big data. Big data means billions of records or millions of records. Okay. Next, interactive analytics and modeling. So we got the data ready. We have prepared our data. We have analyzed the data. We have got the trend, how the data is distributed within the columns of the entire table. So the next part is model development. That's the major portion where entire efforts goes, and this high performance computing engines are required to execute the models, because they will give you a trend, they will give you the predictions, they will help you to decide the future in terms of how the growth will be. So if you might have seen the Shark Tank episodes where the sharks ask the presenters, what is your prediction for this year, and how are you, in the last year you did this much revenue, how are you expecting, how much you are expecting in the coming year, or let's say down the line, 2 or 3 years later. So how those numbers are coming, this all because of linear regression, logistic regressions, predictive modeling. That's all because of modeling, all because of models. So surrounded by data, we are generating data, we are in data, we are in a seabed of data, I would say. You might have seen the Netflix, the Amazon, any video platform, the YouTube, where if you start watching on any particular topic or any particular movie from a dedicated category, then these applications will reflect the similar content for you. If you start looking, if you start watching reels or for a particular channel without subscribing, then next time when you open your Instagram or when you open your YouTube channels, the subsequent or the related reels or the information, the videos will start popping on your screen. How it is coming? It is all because of modeling. It is all because of the data, the trend they are capturing in the back end, right? So it's all data, and they are using high computation resources. It is quite complex. The Netflix algorithm is very complex. Okay, building a model, and if you see, if you can see this pipeline, we call it as a pipeline. This entire pipeline where all the different branches. So these branches, these are the different algorithms. Okay, you can use linear regression, you can use logistic regression, you can use let's say machine learning algorithm, for example, grid boosting, XG boost, different modeling algorithms. So let me tell you one thing. What is model? Model is an expression. It's a statistical expression like y is equals to fx plus c. So I will give the value of x and c, and you will give me based on some expression, you give me the value of y. That's my output. So in terms of, let's say if I talk about based on the credit card, because I on day-to-day basis, I deal with the credit risk credit risk of in the fintech institute. So I can talk confidently on that area. So what will be my credit score? So credit score will be based on your salary, based on your expenses, based on your transaction behavior, based on the number of members which you have to feed in your family, based on the demographic location where you are living, based on the average balance that you are maintaining, based on the transaction behaviors, type of transactions, amount of transactions, how frequently you are withdrawing your money from the ATM. So all these things are getting captured. I'm repeating these things again and again so that you get some understanding, you get some an idea that you are sitting on a blood bath, on a seabed of data. Okay. So all these parameters, all these variables, all this information is input to my model. Okay. And based on this information, I'll get my score. I'll get my credibility, whether I'm a good customer or a bad customer. So banks can even now predict that after 3 or 4 months, this particular person may default. So we call it as an early warning signal, where banks get early warning signal that these type of people in my portfolio will get default in near future. So they start calling those accounts. They start calling those customers and redesign their loan portfolio. They may increase the EMI. They may increase the amount of the EMI that you are paying. So EMI that has two components: the principal and the interest amount. Either they can increase the interest amount or they can increase the principal, so that they can they can get majority of the principal which they have landed to their customers, in case they are getting signals that this category of people will default in the future. So it's all coming through data, through models, through high performance or through heavy computing engines. So consider a scenario where you don't have this much computing resources available with you. You don't have the seamless integration between your data preparation team, between your model development teams, and how difficult it will be for the bank to bring such information or to generate those trends, right? So that's the challenges banks are facing. And it's not only about the developing country. Even the developed countries are also in a same race. Managing your models. So the next step is, in the previous step, I have developed my model. So I may not have a single model for my development, right? I can have 10, 20, 100 until 500 models. No limit on the upper side. So there should be a platform, there should be a system where you can manage your models, because the data, the models that were working before COVID all got disturbed after COVID because of the pandemic. The data got changed. So underlying data has changed significantly. So they have to retrain their models. They have to keep training the model with the new format of data. You might have seen the the people who were earning, let's say, lakhs or 2 lakhs of income, and they had a good salary, or they had a good average balances in their account, they were struggling to pay the rentals. They were struggling to pay their dues, EMIs, because they got fired from the organizations. They don't have the ongoing money, or the current new money feeding into the account. So the model, the existing model, which was not giving me the alarming signals for that category of people, they have started defaulting. It was not because of their, I would say, their incompetency to pay the debt. That was something that happened because of the pandemic, the situation, the external environmental factors. So you need to train the model in different scenarios, in different situations. So that's why we have this manage models, where you manage your existing models. You're not developing a new model, you are managing your existing models, retraining it with a new sample of data, with the new categories, with new, let's say, the data of festivals, the data of the normal, because usually in festivals, what we observe is people spend a lot. So at that time, the expenditure, the income, the ratio of expenditure versus the savings gets disturbed. So, right. So bankers do consider these factors while developing or while maintaining the models. Okay. Okay. Next is develop code flows. Code flows is what we have seen. You are preparing the data, you are developing a model, you are managing a model, you are deploying a model to get the better decision, the business insight. So there should be a proper end-to-end flow where different channels, different personas like data management team, the IT team, the modeler team, the validation team, the regulators can come together under a single platform, can come together on a workflow, so that based on their personas, they get their assigned task, they complete, the task that is be assigned to them, and they move to the next task, or flow gets moved to the next persona. So that this is something the code flows. Okay. Model development, as I covered, so that was from the different modeling algorithms. Here you can use the different models to compare. Like, if let's say you have developed the logistic regression model, you have developed the XGBoost model, you have developed the gradient boosting model. So which model suits well to your geography, which model suits well to your current portfolio, which model suits to your current campaign. If let's say I'm running a big billion days campaign, so I should have something to compare based on the different algorithms on a same data. So whatever model fits well, I will use that model to predict my future with regards to the number. Okay. I will take a pause here for a while and check if you guys have any question around this. All good? Is there something that you can relate with uh, with, with your expertise, or something that I'm covering completely out of the box? Okay. So next is again, so these all are the sections which are talking about model development, like different pipelines, auto ML, then ML libraries. We system comes with the with the template. So if you see this slide here, we have the data which is coming from the data source. Then you are managing the variables, like whatever, if you want to reject or include any particular variable, then you have the open source code node. Okay, you have the decision tree. Okay, this is the Bison neurograph. This is the logistic regression. So all these different algorithms are being used in the pipeline. So later, if let's say another person comes and start developing a model, so they don't need to redraw these pipelines again. They can use these templates like class target with auto tuning, with interval target, with the risk modeling. So all these pipelines, you can create a template for those models or those pipelines, which can be reused by the other resources in the organization, right? Decisions. That's the I would say the end of the entire model development life cycle, which is based on the generative AI, trustworthy AI, and data synthesis and data prediction. Okay, so decision is something. I got my data ready, I got my model ready. Now I will define some business strategies. I will define the business rules. It's simply if and else. Okay, if age is greater than 18, then I will start the credit card approval process. Okay, if age is less than 18, okay, I will simply reject the application. Now, if age is greater than 18, what is the salary? Salary is greater than 50,000, then I will move further. What is the credit bureau score? So credit bureau score is coming from CIBIL. The score is coming from, let's say, Equifax. The score is coming from Experian. So you can add the different business rules which every bank does. Okay, and these rules not only from the credit card portfolio. This can be even in universities. They can you might have seen the minimum criteria is, let's say, with 12th 70%, or let's say the 65%, then they should have AICTE, the AIEEE exam. Some universities conduct their own entrance exams. Then several parameters. So based on those, your eligibility criteria gets defined. That's all the manual process. But if universities start adding some automated way, okay, they can write these eligibility criteria in terms of the business rules, which will give you the final criteria whether this student should be entered, should be allowed to for admission or not. Okay, something on the same lines. If I talk about the score, so score is something after end of every semester we are getting the grade, like 9 pointers, 8 pointers, based on the CGPA. So how does it get calculated? Based on the marks obtained by the students in all the subjects, then relative to the, because CGPA is relative to the all the group of students. So it's all like you get the aggregated score of each student in a class based on the marks obtained from in each subject by that student. So each subject is a variable for a model. Okay, later it gives you the final score. So the average or total, whatever the algorithm is being used, that's the function which is being used in a model. So I try to relate or try to correlate the models which is being developed in banks versus the situation or the scenario that you are into on your daily routine exercises or in your day routine. Forecasting. So probably that would be the my last slide, I guess. Yes. So forecasting is, again, that's the prediction. You are predicting or forecasting what would be my future in terms of the revenues, in terms of how my sales number will be if I will run this campaign in this region during these festival days. What will be the outcome of this campaign? If I'm running a big billion days during my Diwali festivals, during my Republic holidays, during my different occasions, then what will be the number or the total the average number that I can expect based on the trend observed from last 2 years, 3 years, or 4 years. Okay, so it's all about how are you getting those numbers. So if you might have seen that people come in different surveys and say that 70% of people will be having this much facility by end of this. Or you might have seen the predictions from Mahakumbh, like, okay, like they were predicting to have this much figure in crores that they will visit the Prayagraj. So how could they come up with these numbers? It's all because of the models, the forecasting algorithms, the governments, the IT panels back in the governments are using based on the trend, based on the people who are traveling to different places, the how the prices for the airlines get increased over the festival seasons, because they know people will travel. And it's all like demand and supply, right? So they already know the trend that during these days people will travel a lot, and there will be a lot of demand. So either they have to supply, they have to increase the supply, or they have to increase the prices. So eventually it's all because of the trend and the forecasting algorithms that they are using in their systems. Okay, so I tried to keep this short from the slide perspective because I wanted to share the live demo with you guys as well. So I will quickly share my screen again to walk you through with the live demo of a solution. Give me a second. I will reshare my screen. Let me know once you can see my screen. So this is the model platform where you develop your model. So here the data is coming. So that how data looks like. So it is something like maximum number of transactions done in last 6 months. Okay, minimum transaction done in last 6 months. Total annual fees paid in last 6 months. Okay, so this is something my data trend. And in the last, I have ever paid 30 DP. 30 DPD means, let's say you have a credit card payment, you missed to pay the payment. So for how long you didn't pay your credit card bill? So it's like days past due. DPD stands for days past due. So these are the terminologies that you should be aware, because everyone is using credit cards, right? These days, everyone is using all these things. So here we are developing a model. So I can use loss regression. I can use any modeling algorithm like in this reject interference node. Then I can use different algorithms like gradient boosting, linear regression, model composer, neural network, quantile regression. Okay, all these are the terms which are linked to the statistics. It's all about statistics. You are getting predictions. You are calculating the median, average, several other XYZ number of statistics it comprise of. Okay, like Bayesian additive regression trees. I will not be able to cover these models algorithm in detail because for this someone should have a great insights from the stats. And once you start learning the statistics, all these models, everything will cover like one by one. Okay, so here what we are SAS as a platform, what it does is you can get this entire software as a the university edition. Okay, you can have a trial based edition software as well. You can uh, create a SaaS profile and can get everything and can start exploring how it works, and you can evaluate how you can bring these technologies into your day routine exercises. Okay, how you can bring this type of latest tech into your current ecosystem. I know we have good. If I talk about from LPU perspective, I know we have a good IT department. They are maintaining. I'm not sure. I forgot that system, which we call it as the backend system, where we used to get our attendances, the marks, the assignments, everything. We have that portal. So lot multiple like big data we do have from our students. We can generate a trend like which like in some trend could be what were the subjects throughout the BTech. People, the students were struggling to obtain a good marks. Then what can be done to improve so that the upcoming students can do better in those subjects? Should we add more intuitive curriculum to those subjects? Should we add some more PPTs, something like more live sessions or something like can it can be anything. So just a simple example how we can include this type of analyzing the data based on the historical data to make the future better. So all these things can be done. Okay, then here you can compare the different algorithms, can do everything whatever you want to do from this data with regards to you get your entire scorecards, everything here. You get all the statistics. It's all here. So everything is under single umbrella. This is what banks are now using it. And it's all the latest technologies. It's part of the technology. If students are aware of these technologies during their engineering days, then it will be very helpful for the students to secure a good numbers with regards to the composition, with regards to get the better footprints in analysis. Yeah. Okay. So this is what I wanted to cover for today. Ajay ji, would you like to have a quiz?
Give.
And if you have any query around data, if what we covered today on the high level, just let me know. We can use the remaining 20, 15, 20 minutes with our discussions. Please feel free. It should not be like I'm talking to, talking to myself in a computer. At least
Quiz is floated. Please attempt this quiz. I wish all the 68 participants attempt the quiz. There is one new message. What message is there? Oh, Borkar Saab says he's done it.
Navjot has also said, good. At least we are getting some participation. I will be sharing these slides as well with you, Ajay sir. The quiz is already being shared with you, so you can circulate with the. Ajay sir, Ramya, she is asking for the link again. Could you please share the link?
Of quiz?
Yeah.
Ramya, the link is there.
I'm not sure, Ajay sir, whether because usually this data engineering, the data scientist, all these curriculums have been added into the engineering syllabus in
These are
the
added.
different
These are
like
added
if
in
we
LPU.
have you added? Not sure. Yeah,
Data.
that's great because these are high demand. Yeah.
In LPU, we revise our curriculum after every 6 months. So it is
Yes, I know.
added. But I don't know about the other colleges. They should also do it.
Yeah, because that's why I try to give a simple example. Like you can use a simple like the student score of your earlier batches and can see whether in which subject people are struggling to obtain the good marks. If let's say I talk about the subject with which I used to get quite that subject was quite boring for me as computer graphics. It came in semester 5th or 6th, I guess. Yeah. So people were not interested to learn computer graphics because that was all with all cathode rays and that. So if do we really need that subject later, or do we need to do some intuitive activities so that we can get or we can involve or we can include the students involvement so that they can start reading this subject with the interest. Just an example. Okay, so these all analytics can be even used or deployed within the colleges, within the universities, so that they can do better uh, for, for the upcoming students. Simple example.
Excuse me, sir. Good evening.
Yes, ma'am. Yes, ma'am. Navjot,
Sir,
ma'am. Tell
I
me.
had a concern, like, is there any recommendation for any specific or basic course that anyone, maybe our students, maybe we, like in this area, like as a
Yeah,
layman, if I start with,
yeah,
is
yes.
please recommend a few.
Yeah, okay. From the data scientist or talking about cloud computing or data scientist or this data analytics.
For data analytics. Like sometimes kids are
Okay.
very much
So
confused with the we have opted for data science and no one is hiring us directly as a data scientist and what to
okay,
do now. So with
okay.
that perspective actually.
See, data scientist is a broad term. Okay, it's like entire sea of everything. So writing a SQL query is not data scientist. And usually people anticipate if I'm able to read data from a table, I can update a table, I can update the values, I can insert data from a form, then I'm a data scientist. You are not data scientist. You are just the person who is reading the data from a table and getting the insight. So data scientist is that will eventually take the data, will analyze, like I gave an example of big billion days. I can give an example of the marks obtained by the students in the subjects in let's say in last 5-6 years. So if you are getting such insights from a data, that is data analytics. Or data scientist comes along with data scientist is someone who does data analytics, who manages data and generates a valuable insights, predicts the future, predicts or forecasts the future. Okay, so that is what data scientist does. Now there are several courses on Udemy, Coursera. So and but the problem with all these courses, or I would say students would get challenges, they directly jump to data scientist course, but forget to cover the prerequisite. The prerequisite is you should have clear concepts for sequels. You should have exposure to one programming language which deals in data, like SAS, Python, R. It can be any language. I'm not saying SAS is must.
Right.
SAS, if SAS, good. You get opportunity to work with MNCs because all the MNCs, all the big banks are using SAS as their data platform. They
Right.
are using Python, but their main core is SAS. Okay, that's
Right.
one thing. So two things. One should have clear concept with SQL. One should have exposure to, let's say, Python, R, or SAS. Then you should have some insights of stats as well. Stats does not restrict until mean, median, average. No, it's not stat. It is just the A of entire A to Z dictionary. There are a load. There is PQR, XYZ also in the stats. So three things: SQL, programming language, and stats. If someone has its strong command on these three things, then it's done. Then jump to those courses where they will explain how to use the packages of Python which are readily available, like NumPy, any other libraries. Then you should start going towards data scientist, data analytics. So these are the baby steps which you have to take before jumping into the courses. So I don't recommend or I don't uh, give advice to anyone to directly go and take a course of data analytics. No, first of all, clear these fundamentals. You get to know, because statistics is very boring. It's not a cup of tea for everyone,
Right.
right? I don't like numbers, but I have to because that's my role. Okay, so it's all about that. So I guess I answer your question.
Understood.
Just now,
Thank you
right?
so much, sir. Right.
Thank you, ma'am. Any other query? But that was the good question, and it can be an eye opener for others as well, who are uh, guiding or recommending their students their how you can progress in this direction of data analytics and data scientist.
Okay, one more question, sir. Question is from which I have to read the name. Yeah, question is from B. Ramya Sri. She says
Yeah.
that she has a background of electronics engineering, EC, and she wants to do PhD. So which domain she should choose related to CSC, or she should choose PhD? Sir, before you answer, I would like to say that the second question, quiz question, is also punched.
Okay. Let me read. So I have a less experience in teaching in the call, seeing all high level professors. Okay. I may not be the best person to answer this query because I've not done my master's, I've not done my doctorate. I'm a BTech graduate. So with my understanding, I guess changing a domain from electronics to computers will be pretty much hectic or will be quite hard for you. But I can see a lot of doctorates in the session. If anyone can volunteer to answer this question, I will really appreciate, because I don't want to give a false uh, recommendations or which I don't. That's not my forte. So if you have anyone in the audience who would like to volunteer to answer this question.
Sir, what I want to add on to this is, PhD is the kind of degree where until you're not interested, you can't work upon. So it's better to go for the field where you have a basic knowledge, and I believe where you can, extend your interest as well. So quick switching isn't like recommended ever until you do not either have interest or you are very much strongly, motivated by yourself that, okay, I'll be, definitely taking up the things further. Because research is something like you sometimes force yourself as well. But that force would be good if you have a little bit prior, interest and knowledge. So all of a sudden, if one is very much new to something, so it sometimes becomes quite hectic, because me being a scholar as well, so it is somehow I can relate where ma'am, I believe,
Yeah.
to go for. So better is
Yeah.
yes, go for whatever the basic knowledge you have, and then you can further definitely extend. It'll be a better way. Otherwise, it'll be quite boring researching something where you have no idea at all. So that could be
Yes.
of the thing.
I think
I just want to say one thing, that in electronics and computers, there are many things which are common, and you might be doing something which is interesting and which you are interested also.
Right.
So find out an area. If there is something common, you can go. And since I am also from electronics, we can find many areas which are common between electronics and computer science. So you can find out that area, map your interest, and then go for PhD. There are many electronics engineers who are doing with the masters, in fact, and PhDs in field of computer science, normally related to computer science areas. Because data present, I saw some people doing robotics, PhD
yes.
in robotics. Like this is entirely related to data. And there are some more. I saw mechanical engineers doing all PhD in robotics, because it is related to them also. You can map any other area. If you find any other area, you can do it.
And I believe in PhD you have one section of dissertation, right? You have to make some research, prepare that research paper, and present, if I'm not wrong. So, and that research paper involves a lot of effort, deep understanding of that topic to bring something new or like innovation on the table to get the title of doctorate. Correct?
Right, sir.
Yeah. But yeah, lot of big respect for all the doctorates because it has a lot of effort to get done. Okay. So any question?
Have any question you
I
can
encourage
ask?
you. Yeah.
Yeah. You can ask, and because as far as Sanchit ji is concerned, he is from the industry, so technical knowledge, maybe the updated technical knowledge, you can get some important help for your academic providing academic inputs to the children also. That we normally when we attend.
Yes, and right. And I can, if you need some industry insights, that I can also provide because with my job role, I travel to multiple countries, to multiple regions where I do talk to different bankers, the chief risk officers of big banks, and what is being in demand at this time from the data perspective, from different domains. If you have any query, please feel free to ask so that we can give these inputs to the students and they can do something good during their starting stages of their career.
Yeah, students feel connected when you talk something related to industry. They feel connected.
Yes,
And
right.
they feel confident also that they are getting the right inputs. Normally, we don't give no wrong inputs, but when you give inputs related to the examples, real-time examples related to industry, and that too of your experience, and that there is nothing better than that.
Yes, agreed. So, and even I guess Ajay, you have my contact details, and if you need any insights anywhere, please feel free to let me in. I will try my best
Yeah.
what I can
What
contribute back to the community from where I have learned.
should not make it like the affair from January 27 to Feb 1. All the professors over here, professors and industry people also there, two industry persons are also there. So you can, we keep on connecting, we keep on sharing new ideas, new developments, new whatever you get, uh, feel that you can share that can benefit others, you can do it. The WhatsApp group will be open.
Yes. Okay. So shall we?
Yeah, any other question, ladies and gentlemen? I just want one more because if someone is from data science, teaching data science, we can ask that you said about yesterday was talking about uh, more about fintechs, means financial
Yes.
companies were giving loans and all the things. I just want to ask one thing. How is artificial intelligence now helping in making it more better, the data science, data analytics?
That's the artificial intelligence where you are predicting or forecasting your up the near future. That's the artificial intelligence. So you have developed algorithms to which, if you are giving a data, you are providing some inputs, it is giving you the results. Like I said, the co-pilot. Okay, if I okay, let me give you the right live example. Okay, let me open my screen, share my screen, and I'll give the live example. You ask any questions, sir. I will explain. I'll try to address from Copilot. You ask any question.
Tell me about the AI tools helpful for learning and development. For example, this is my question.
Yeah. Okay. Tell me tools which can help me to learn
No,
data
no.
analytics.
I'm saying, tell me about the tools which can help me. You can say
Yeah.
you can say about the about research.
Yes. So I'm giving this input to our system. So there are this all information is available in different sources. Okay. So you can see like the Tableau, the SAS, the Google Cloud, okay, the R, Python, everything. Microsoft is on top because Copilot is owned by Microsoft. So they eventually keep this on the top. So this is something they have. So here you can see all these things, right? So it can do anything. So this is artificial intelligence. From now it is coming from these pages. So if I click on this link, this is a page. So the model is written in the backend, okay, which is taking information from this URL and compiling and giving you in a better way. So you don't need to search on Google for anything. Just write your program here, write your query here, and that's it. Simple example. Help me to write sick leave to my manager having pain in stomach. Simple example, nothing. It will give me entire email. That's it. I hope this message finds you well. I'm writing information and experiencing severe stomach pain and will not be able to come for work today. So that's the artificial intelligence. You have given a simple statement. You gave, okay, what problem I have pain in my stomach. That's it. That's artificial intelligence. So no need to write anything. The main effort, the main knowledge is in developing this resource, this models, this data. This is the beauty of analytics, right? So you can directly copy it and paste in your inbox. Simple, khatam, done. That's how beautiful it is. You got it, sir?
Yeah.
That's the artificial intelligence. So that's how it works. So we have the data available over the internet in various forms, in web pages, and like millions of sources are available over the internet. And what these systems are doing, this chat GPT, the open AI, the scope, what they are doing, they are hitting the query on the back end to those resources, generating some information, insights, the important information, the useful insights, and projecting in as a presentable information in front of you. This is what data analytics, this is what data science, this is what artificial intelligence means. I guess you get some real-time experience or real-time understanding, right? Okay. I can write an entire book on by just hitting titles on Copilot or on ChatGPT. I can write everything. I can get any content in any format. So it's all, that's why I said we are sitting on a seabed of data. We have a lot of data around us. The only thing is we have to evaluate, or we have to start functioning or training our mind. How do we want to generate the insights from the data that we do have? I'll give you another example. Most of people are using this postpaid mobile connections, right? So how do you get the credit limit in that card for your number? That's again based on your usage. Mobile telecom companies are utilizing the data, getting insights, how frequently you are paying your bills, what is your usage, shall we increase your limit? You obviously get a message for credit card as well. Okay, you have 3 lakh of monthly credit limit, and based on the usage, we should increase your limit because you are spending a lot. So from where you're getting these messages? It's all coming from data. It's all coming from system backend. There's a big team sitting in the backend who is doing entire operations. They are all data scientists. So if students will start training of these data scientist algorithms, these data scientist curriculum since their engineering days, then it will be easy for them. And future is data analytics. Right, sir? Ajay, sir?
Great, sir. Sanjit, sir. Just for
Thank
today,
you.
it was nice talking to you. We will be in touch for many other programs.
Yes,
like this.
definitely.
We
Definitely,
keep
sir.
on doing programs on data science, data analytics, and other topics. Now, only one request that please send your PPT so that we can send it on
Yes.
the group. And tomorrow, I will request to join us tomorrow at the time of valedictory so that we can celebrate the success of the program. I will
Thank you,
send
sir.
you the
I
time.
will. Sure.
Okay, sir.
Sure.
Thanks a lot.
Thank you, sir. Bye, guys. Thank you.
Let's have a break of 5 minutes. Give a thumbs up if you want, otherwise we can start. No, I think people do not want break. So we have one person from the lot who was given the responsibility to brief the second session, Gagan sir's session. And she not only given responsibility, she volunteered. So Dr. Manjot Kaur, I can see you, everyone can see you. So can you brief the yesterday's second session before we start today's second session?
Good evening, everyone. Am I audible, sir?
Yeah.
Yeah. Good evening, everyone. I'm briefing out the yesterday's session. Gagan Sharma, Head of Informatics at the Melbourne Brain Centre, Royal Melbourne Hospital, Australia, delivered an insightful talk on MPI programming. He began with the introduction to MPI, explaining its significance in parallel commuting and why it is widely used. He then covered key concepts including message passing, topology, communication model, and process synchronization. Performance considerations such as scalability and optimization were discussed to enhance efficiency. He also explored essential tools and libraries that facilitate MPI development, The talk highlighted the advantages and challenges of MPI from high-speed computation to debugging complexities. Finally, Gagan Sharma shared real-world applications, particularly in medical imaging, demonstrating MPI's impact in the field using brain tumor examples. It was an engaging and informative session that provided valuable insights into MPI programming and its application. Thank you, everyone.
Thanks a lot, Dr. Manjot. I would like to say that it was a good observation. Dr. Mr. Gagan Sharma is into medical imaging, and he is IIT's exoskeleton is gone for trials, clinical trials in his company, Proximate. They are
Yes.
working basically on data science. We had a meeting with Gagan once he visited us last time, and came to know about many other things which he's doing. So basically doing good, and he was taken to a lab of GPU, where GPU, I think you might have seen it, is block 38 here from NP.
Yes, sir. So
So
one thing I found very good in his session was that he started his session by thanking his all the mentors, faculties, those who upgraded his career. That was what I found unique in any expert talk. Usually they start their talk, but he praised everyone, all the building pillars, those who supported him during his all this career study towards his medical image processing. He mentioned
great.
names in his PowerPoint presentation also. That was very unique and it touched, like it was really something unique and beautiful
That's
to
great.
all.
That's great.
Yeah.
Yeah, he does that.
Yes.
So we have our another resource person. I would like to introduce Mr. Sir. Hi, Saurabh sir. If you can listen to me. We can see you, sir. Uh,
Oh, yes, yes, I have joined. Yes.
so Dr. Saurabh now is senior architect at Synopsys, and tries to invent and design new AI/ML techniques to improve overall C design life cycles. So his core expertise is LLMs, right? NLP and ML-based job scheduling on cloud. He has done his PhD from Purdue, MTech from IIT Kharagpur, and he has been published many research papers, definitely posters in IEEE and ACM conferences. Now, I was going through your LinkedIn profile, sir, and
Mhm.
we have to research about the resource person who's coming, and it was very interesting that while working as RA, research assistant at
Mhm.
Purdue, you managed the HPC lab, deploying OpenStack-based clusters and Hadoop environment for large-scale data processing. So you
Yes.
did grid scheduling algorithms, MPI implementation, and cloud-based HPC solutions with prior roles to in Avitech IT Solutions, Purdue University, and multiple publications in AI and cloud forensics. That's very interesting. So you are a key contributor in cutting edge HPC and AI-driven cloud technologies. So, sir, we are eager to hear from you. So, without much ado, the platform is yours now. I'm stopping my share and request you to take charge of the platform.
Sure. Thank you so much for the introduction. And let me share my screen. Are you able to hear me properly?
Yeah, you are quite audible, sir.
Okay, thank you. Okay, so good evening, everybody. Um, I think I think it has been already been a long session, and it has been I mean, all the topics that has been covered in the various sessions are very interesting. So one of the topics that I'll be covering in this session is primarily related to HPC file systems and data management. And I have worked in one of the largest data centers, academic data centers in the US, which is in the Purdue. Like it is among the top 5 data centers in academic data centers in the US. And file systems and data management is one of the key aspects, especially now when in the age of AI and generative AI, it is becoming more and more critical because data is your key asset when we talk about any of these systems, any of the modern systems. It becomes a key asset for your any fundamental infrastructure. So as part of the this talk, right, I would be covering like the fundamentals, what HPC file systems are. Then we have I've picked 2 of specific file systems that we can talk in detail about. Those are Lustre and GPFS. GPFS is from IBM. And data storage strategies for HPC workloads and different IO performance tuning and best practices, and like what are the tools to do benchmarking, and then we can jump over some question answers. Uh, so if you see some of the storage servers, if you happen to visit to any of the large data centers, you would see the storage racks are typically in these forms, like where you have several disks coming to the rack servers, and the storage server class machines are typically having like 100 disks in a single server, because that's how the typical distributed file systems are designed to be. So these are some of the examples, but there are many more. So what are HPC file systems and why they matter? Why is it why is it so important to the whole cloud computing or distributed computing? Why does it matter so much? So HPC environments generally and process massive data sets. We are talking about like several petabytes of data. Just to give you an example, uh, at Purdue, I was part of the Purdue data center, and we uh, we participate in the CMS project, which is primarily capturing data from CERN for particle collision experiments. So CERN in uh, uh, which is a scientific organization very similar to NASA, if you know, they conduct particle collision experiments where where they collide electrons, and the energy that is generated, they study that, and in this process, they capture all the data that is generated during the particle collision and the emission. And all of this data is so massive that every renowned technical university or institutes like ISRO or NASA, they all collaborate to capture this data because it's in petabytes of several petabytes of data, and every institute tries to preserve some amount of data in their storage. So these are all Hadoop-based storage systems, HPC systems. And when when physicists, they want to run some experiments on this data, they write a query in a Hadoop. They write something called a pig query, and when that query is executed, it is it extracts data from various geographies, it combines it, and then finally produces the outcome to the whoever the scientist is who is writing these queries. So it submits a HPC job, which can take maybe more than a week to finally process it. And even though like they have massive compute, but the amount of data that they are trying to query is so large and it is so geographically distributed, so that the HPC cluster that is processing this query, and it's in queue, so it may not get executed immediately. It may take some time. But to process this query on the Hadoop cluster from various places, it can take many days. And then finally, the physics scientists have the output with them. So these are the kind of this is just to give you an idea like how massive the scale of these data sets could be, and how critical it can be. So traditional file systems cannot meet the concurrency. Traditional file systems, when I say like the file system which are generally on your laptop or on your or general server machines, they cannot meet the concurrency or the bandwidth or the scaling requirements, like typical HDD hard drive, which is in your laptop, or SSD hard drive in your laptop. They cannot meet this. And even like NVMe drives, which are part of these large clusters, they have to be configured in the sense of in a typical architecture, so that the concurrency, bandwidth, and the scaling requirements can be met. And the third point is the parallel file systems. Parallel file systems distribute data across multiple servers and storage devices to handle high throughput, low latency, and scalability to petabyte and exabytes of data. So one of the key things is like when you have these large data sets, you have to also think about replication. You have to also think about what could be the best throughput that you can get, and can you even scale to petabyte and exabyte scale? So now let's talk about the HPC data management part. Like, how do we typically manage the HPC data sets? And so the first thing is parallel I/O. Parallel I/O means there has to be the input output coming from your file system has to be embarrassingly parallel. Like multiple processes should be able to perform I/O simultaneously without any interruption. The second is striping. Splitting Striping means splitting data across multiple disks or servers to basically boost the I/O performance. Because when you can imagine when there are so many processes trying to write and read the data from these disks, the main challenge is how many copies of the data you can create across the cluster so that the access, read or write to your disk doesn't become a bottleneck. How you can boost the performance for that. Third is metadata services. Metadata services is meant to be specialized servers that can handle the metadata operations, like like let's say when you have millions or billions of files on your file system, you want a metadata service that has already indexed each and every file on your file system, and it maintains things like file names, permissions, location of the file, so that the search of any file or any kind of file or directories becomes super fast. Then comes the redundancy and the reliability part. So in terms of the file system terminology, it is called RAID, which allows you to do replication on your disk, and it ensures the coding for fault tolerance. Because RAID helps you to create replicas of your data, and that helps basically, in case of any kind of disaster failure, you should be able to always recover your data from your redundant disks or like your replica disks. So that brings the reliability into the picture. Now let's talk about the parallel file systems, or what, like there are, as I said in the beginning, there are many of the parallel file systems, but in this particular talk, we will try to focus upon two of them. One is Lustre, and the other is GPFS, which is from IBM. And these are like one of the two leading parallel file systems, but there are more, many more in the industry right now. So both Lustre and GPFS, they are designed to handle HPC workload at large scales. They support like thousands of clients and millions of clients. They provide a very high bandwidth throughput. Uh, and the core features that they support uh, is all what I discussed in the previous slide, that is including the metadata handling. They support the data striping across multiple storage targets. They have advanced caching and locking mechanisms that that improvises the speed for the disk IO, that makes it very efficient for the frequent write and read to the file system. Now let's talk about Lustre. Where does it how it got originated? So Lustre actually came from the word Linux and cluster. So large scale cluster and Linux, uh, it started with the combination of the two gave the name Lustre. Now it is a very widely used top HPC file system, very widely used. It is one of the popular file system that is used in many of the cloud data centers, at like IBM Cloud or Azure Cloud or AWS Cloud. It is one of the very popular file systems for HPC workloads specifically. Uh, uh, like uh, like for example, like the top 500 supercomputers, many of them are built on top of Lustre file systems. So it was developed originally as an open source project by Sun Microsystems, and then after Oracle took over Sun Microsystems, they took over it, and then it is now primarily community driven. So it is a open source, which is primarily open source community is driving it. Now, this was architected for large-scale HPC, high input-output throughput, and scalability to tens of thousands of nodes in a very large server HPC cluster environment. This is a diagram that represents the Lustre architecture, how it looks like. If you see on the top right side of the picture, it shows that there are three or actually four major components: management target, management data, and like the DNE metadata targets, the metadata targets, and actually the object storage targets. So let's go over one by one what exactly each of them means. So the management server is basically it stores the configuration for the entire Lustre file system, and which includes like various configurations like related to performance, related to disk tuning, related to the scalability. So all these configuration options are stored in the management server. Then the metadata server is a file system namespace where you are trying to keep all the meta information about the files that you have stored. So like it could be file name, it could be permission, it could be ownership. This actually helps a lot in defining the role-based access management for these files, especially in case of when we talk about in terms of AI or machine learning. What when we try to develop models or when we try to do training of a large model with this kind of data set, right? This metadata server plays a very critical role where because that defines like what data access you have for training, what you don't have. So all the role-based access for any kind of training or any kind of large scale application, it helps you to define your access policies. Third is the metadata target, which is actually a physical storage device which handles all the metadata. So metadata server is just a namespace, a file system namespace, but the metadata target is the physical storage device which holds all of this metadata. Then let's talk about the object storage server. This manages all the read and write to uh, the object storage targets, which is which is responsible for all the input output, and it handles the scalability of all the incoming reads or writes, and how do we distribute it across the cluster on multiple disks, multiple nodes. How do we distribute it? And same like there is a server layer for this object storage, and there is a physical layer. The physical layers contains where the physical disks which actually stores these file data, these files, or like all the data that you have in the cluster. So if you see the right bottom diagram, it actually shows how the management target, metadata target, and these object storage, they are connected through a very high speed data network. It could be a omnipath, it could be a InfiniBand, or it could be like a 10 gig, 40 gig, or 100 gig network data network line. So this is very critical because the network layer which is connecting all these different components in your file system, uh, that defines the latency or throughput of your file system. If it is something like InfiniBand, you are going to get the best performance out of your file system throughout, because the communication between all the three layers will be super fast. But if you have a 10 gig network line between these three components, then of course the performance is going to be much slower compared to what you can achieve with a omnipath or an InfiniBand. Now let's talk about the advantages and the use cases, and that some of the common use cases for Lustre. The common advantages is like high scalability for the metadata and data services. It is very flexible for the network support. Like it support multiple backends for the network, like InfiniBand, OmniPath, or Ethernet, like 10 gig, 40 gig, 100 gig. And it has proven performance on large scale HPC systems. Like that's why it is part of some of the top 500 supercomputers that exists out there. And it is part of a lot of them. And some of the common use cases that we can talk about is like scientific community computing with massive data, like it could be climate modeling, or like, let's say, physics modeling, where you are like, let's say you are trying to do something with protein structure. Um, and then it could be data processing in national labs or like supercomputing centers. So even I mean, a lot of India's scientific institutes, they use Lustre as one of the primary file systems in their supercomputing environment. Uh, then the large scales, it could be very useful for large scale simulations, like it could be used for circuit simulations, or it could be used for chemical simulations, or that requires parallel read and write at scale. So if you have created some kind of a very complicated something like a circuit simulation, which even before you actually do a physical synthesis of the circuit, you want to run a simulation that runs on a very large scale HPC cluster. It could be very, very useful in those scenarios to run the simulation on these parallel file systems, where the read and write is very performant. You have the scalability uh, at your hand. Okay. Okay, so now let's talk about the GPFS, which is which is a file system that was developed by IBM. So this is IBM's high performance cluster file system. This is renowned for robustness, again, scalability and enterprise features. So compared to Lustre, which is an open source file system, GPFS is primarily an enterprise file system, which is like very predominantly you can find it on IBM Cloud, because IBM Cloud is one of the largest providers for HPC workloads. They have been traditionally uh, providing to all the enterprise companies the compute and the environment for HPC workloads. And the key attributes, they have a something called global namespace approach, where you have you can put your data in a global namespace. That means it is accessible. It is public within the file system, so like open to all. And then there is a policy-driven data management, where you can define your tiered storage, and that means that you can uh, write policies about about the accessibility of the data. You can write policies about the throughput, like if you want to have a cap on the throughput, you want to manage the latency. So you can write policies to manage all of these key attributes. Then the third one is the fault tolerance and replication options. So it allows you to configure the fault tolerances, where you can have replica disks, or like it could be 2 replicas or 4 replicas. That means your data can be replicated over whether 2 copies or 4 copies, and you can actually replicate it into cross geography. So let's say you have a data which is in India, but you want to have create a replica. If there are multiple data centers within India, one may be in, let's say, in Gujarat, one may be in, let's say, Maharashtra, you can do a cross geography replication, and that helps you not just uh, to preserve your data and like prepare for disaster recovery, but also serve multiple workloads from different geography, depending upon where the request is coming from. Okay. So this is the GPFS architecture where the nodes and file systems, there is a notion of nodes and file systems which has like multiple nodes. These are called as NSD servers, where NSD stands for Network Shared Disk, and there are client nodes. So if you see on the right side, let's go from bottom to top. You have the Linux operating system where where your portability layer module, which is a Linux module, is installed, and there is a kernel level module, which is GPFS kernel module extension. Both of these modules are gets installed at the OS level, so that they can interact directly with the kernel, Linux kernel, and this is the lowest level in their entire GPFS stack. On top of it, the IBM Reliability Scalable Cluster Technology, that is called RSCT, sits, where they have something called group services, and they have the topology services. This interacts with the kernel modules that at the operating system levels, with both portability layer and the GPFS kernel module. This is the interaction layer. And then the top top layer is the GPFS layer, the file system layer, that is exposed to the end user for us. This exposed layer has a GPFS daemon, which is running on all the nodes. So like, let's say you have 1,000 nodes in your cluster. So on all 1,000 nodes, this daemon will be running. And for the resource monitoring purposes, there is a system resource controller, SRC, which interacts with both all three components, like the GPFS daemon, the RSCT, as well as the OS level components, both kernel module as well as the portability layer module. So this keeps track of, based on the incoming workload, how to distribute the workload on the file system and monitor the workload, like what is the usage, what is the throughput, what is the latency. This helps this resource controller keeps track of everything. So if we talk about the components, so NSD is the abstracts the underlying storage, and it can be either a SAN storage, or it can be a direct attached storage. So SAN is generally network-based storage, and so that's why it is saying it could be that a network storage, or it could be a disk which is physically attached to the servers. So third is the management and configuration, the cluster management tools for node addition and removal monitoring. So what happens in these large clusters, like it is called something called as hot swapping of disks. When let's say you have to add more disks, or like you have to remove disks, these servers are very robust for like hot swapping. When the system is in running state, you can take out a disk, or you can put a new disk and ask the system to reconfigure. It will accept it. It will rebalance all the workload for the new disk, newly added disk, or if you remove a disk, it will remove it from the cluster. So it always tries to self-adjust among what you add, what you remove. Then the data and metadata. This can be co-located with the disk and data disk, or separated for performance optimization. Then we have the advanced caching feature. Advanced caching is a proprietary technology that IBM has developed for a GPFS file system that allows lock management, like file lock management, like while while you are accessing a specific file, or while you are if you have it's a typical reader writer problem when you are somebody is already writing a file. How do you lock it, and how to cache while reading the file, how you can cache, and like if there are multiple access happening to same file, how can you put it in a cache to reduce the IO contention. Okay. Now, let's talk about the advantages of GPFS. It is again integrated tiering and the information lifecycle management. It is very useful in this kind of cases where you have to uh, manage the entire life cycle of your files, like how uh, like when it was added, edited, deleted, and it has a good sense of resilience with replication, whether you use RAID or some other replication approach. It has a cross-platform support for Linux, AIX, or for Windows. So it works across all three different platforms. Windows is one of the toughest one, and not all file systems actually support Windows. So this is one of the advanced features. Common use cases, again, it is very commonly used in the commercial HPC environment because IBM uses this in their cloud offering for HPC workloads. It is very popular in media, broadcast, or life sciences, and also in AI/ML workloads. Also, it is designed for doing analytics because, as I mentioned, one of the key advantages is to have the information lifecycle management. So it is very efficient when you have to do analytics on top of a very on petabytes of data. It becomes very useful to use GPFS in that scenarios. Okay. Now, so just to recap, so far what we have talked about is we have talked about the introduction of the HPC file systems. What does a parallel file system do? Then we have talked about some of the use cases. Then we have talked about Lustre, its architecture, and what are the advantages or use cases for Lustre. Then we also talked about the second variety of file system, that is GPFS from IBM, and its different advantages. So far what we have covered is like the type of file systems and like how do they work, what are the common features. Now let's talk about what is the data storage strategies when you have to use these file systems. What are the best policies, best practices to use these file systems? So there are data storage strategies has like 4 different verticals that needs to be considered. One is capacity versus performance. So you have to always balance between how much capacity you want to increase and how is it going to affect your performance. How they are related is the moment you increase the capacity of your cluster, that means you are adding more and more disks. You have to think about the network connectivity between your nodes. If your network connectivity is not InfiniBand, uh, and it is like a 10 gig network line, then your performance starts dropping. So you have to always balance between, like, if you don't have a very high speed internet connect, then how much capacity you should stop at. And that is a trade-off that you have to do. Second is workload characteristics, which is it is very important in any of the scientific data centers, or like any of the institutes, right, to characterize your workload. Say, for example, the workload that the scientists in working in ISRO will be having would be very different for the somebody who is working on machine learning in, let's say, in IIC Bangalore. Those two workloads could be very, very different. So the characterization of the workload on your data center is very, very important. It actually helps you define uh, the amount of small files that you are dealing with, or you have large sequential files, uh, because the characteristic of small file versus the large files is very different. And the type of file, whether it is a binary file, whether it is a flat file. So the type of file and the size of file matters a lot for defining your input-output characteristic. And what is the access pattern? Is it a random access pattern or a sequential access pattern? To define random access pattern is, sometimes what happens is people who are using the data from these file systems, they could be running experiments which could be very random. Like, let's say you ran an experiment today and then you didn't run anything this week. Then you are running again after a week, you are running some experiments again. So these are like random patterns. So you cannot predict, like, every day you will have some input output from your file system, that it is not predictable. But if you have a sequential access pattern, that means that you are running an experiment which is running for, let's say, 30 days. Now you know, like, the access pattern for each day, right? How it is performing every day, because the experiment is very large and it could be running for, let's say, a month. So now you can very well predict, like, every day's workload. Third is scalability requirements. The scalability requirements, what is the current usage, what is the current capacity, and what is the expected workload, how you can predict the future capacity, and keep adding. You have to always think in terms of how you can scale your storage system, how you can scale your network system. So this is the kind of storage, like, it helps you plan for your scalability. And finally, the data lifecycle and policies. When you are managing these kind of data storage, like, you have to always think about the security, the retention, archiving. So let's take an example for the data center, which is, let's say, holding all the information about all the citizens in India. Like, let's say, all the Aadhaar card information, how critical it is, and how do we ensure that the Aadhaar card details and everything in the data center is, it is replicated, it is archived properly, and you have different tiers of data. That means you have a cold data. We'll be talking about what does a tiered data means, but and who can access it. So the when I talk in terms of security, it covers the role-based access that defines, who can access the data, who cannot access the data. So you define all those data governance policies on top of your storage. Okay. Okay, so let's talk about the data placement and tiering. What is how do we place our data, and what does the tiering means? So the data, there are three tiers: hot, warm, and cold. So hot tier means you want to, which when you want to have a faster and more expensive storage for hot data. This is the data that you are currently trying to access and which is most frequently access data. So let's say in terms of you know uh, uh, like any organization. So let's say if we talk about an organization, let's say you have 1 million employees and you have stored all the information about them. Now, the information which you are trying to access very frequently, you always keep it in the hot storage data, which is typically NVMe drives. Like they're the fastest, most expensive storage drives. Then you have warm storage, which is where it's you can imagine it as a cache layer, where where you where you compromise on the storage tier, like let's say rather than NVMe, you would use SSD drives so that it is cheaper, but it is less frequent accessed compared to the hot storage. And finally, anything which goes to your data warehouse, like the data which has been archived and it is not accessed that frequently, goes to the cold tiers, and these are your slowest file, slowest disk, cheapest disk, which could be HDD storage, and this is accessed only when like you're running some query which is about some archived data. Only then it will be used. So this is how it is tiered. Now, automated tiering is something where you have policies to move data between different tiers like hot, warm, and cold. These three tiers, and based on an access pattern and the usage pattern. So what you can do is from the entire data that you have on your file system, based on the access patterns for the specific pieces of the data in your file system, you can automatically do this tiering between hot, warm, and cold, and make efficient usage of that. What is the benefit? Like it optimizes cost per gigabyte of storage, which is very critical because we are talking about um, uh, like thousands of disks. So even per gig, if you are able to optimize your storage cost, that is a big number in terms of a large scale data center. And it improves improved performance for frequently accessed data. Of course, the latency uh, uh, and the throughput both are impacted highly when you have this tiered approach, because you are able to cache all the frequently accessed data in your hot storage and able to have a much better throughput for the end users. Okay, this is one of very big challenges for that is to handle small files in HPC world. Typically, large files are never a big problem in any of the file systems. And small files are much more problematic because the small files tends to be in a very large quantity, like in millions of files, small files, and they are very hard to maintain because, as you can imagine, indexing these files to the metadata server becomes a challenge. So the primary challenge is when you are indexing like millions of small files, you are basically capturing their file name, location, and all other metadata related to the file and storing it to the metadata server. If you remember the diagram that we saw on both Lustre and GPFS, they both have a metadata server and they tend to store all of this information. And you can imagine if you have like millions of small files, it's a metadata overhead and it's a locking contention problem. Now, how do we deal with this? So there are different strategies that to deal with this. Uh, First one is to use collective IO or create archives of small files. So basically, you can create tarballs of these small files and only untar when you have to access the file. So basically, you will untar only on demand. And if you don't have to untar, you will maintain the metadata of the star file that, let's say you have created a tarball for 1 million files and you have kept the information in the metadata that these are the 1 million files which is present in this tarball. Now, when you have to access any of those files, then only you on demand you will untar and access the file, and then again you close it. So basically, till it is needed, you are always treating all those million files as a single tarball file. So that helps to reduce the overhead. Second could be the metadata performance tuning. More MDS servers, like the metadata servers, we can have multiple replicas of those servers. So that like we can have distributed input output from those servers, and we can maintain different copies of those metadata. Third could be adjusting the file system settings itself, like the striping, block size. You can tune these settings to reduce the overhead of these metadata that you're storing for millions of small files. Okay. Now, let's talk about we have talked about most of the theoretical part that how these parallel file systems run, what are the challenges, advantages. Now the main thing is once you have, let's say, done a setup of your file system, any of these large scale file systems, how do you tune the performance, IO performance? Or how do you measure it? Basically, how do you benchmark it? So the goal is to maximize the throughput and minimize the latency. Of course, you want the IO throughput to be maximum and latency to be minimized. And you always want to ensure this you can scale as the node count grows. Like I mentioned before, that in your data center environment, you always tends to add more and more nodes so that as the data keeps growing. So you need to think about how you can maintain your IO performance as the number of nodes are growing. So key IO tuning layers are, like you can tune it at application level optimizations. You can tune it at the middleware library optimizations. And for that, you can use MPI, which is one of the distributed processing libraries. MPI is one of the most popular ones for any kind of HPC jobs. Then you have HDF5 or NetCDF. You can do the performance tuning at parallel file system configuration or at the infrastructure layer. Like I said, you can choose between the infinity band network or between different 100 gig network or 10 gig or 40 gig. So all these 4 different layers, you can perform your IO tuning. Now, the best practices, these are some of the best practices that are recommended for any parallel file system configuration. the striping parameters, like, what stripe size, stripping parameters, what stripe size or stripe count you should pick. So like it is very different for depending upon the file system that you pick, like Lustre OSTs or GPFS NSDs. Like you have to pick like configure them differently. Then the network configuration, like which one you pick, either InfiniBand, OmniPath. Which RAID level you pick, like you could pick RAID 0, you can pick RAID 5, RAID 6, or versus RAID 10. So when we are talking about some of the large scale deployments, it matters a lot, because the cost of RAID going with RAID 6 versus RAID 10 would be much higher, but it depends upon the fault tolerance that you want to have. Like, let's say if you are running something like, let's say, if how Google is storing all the data that for Gmail or for YouTube, they will have like 40 replicas of your data, so that in different geographies, so that like in no scenario they're losing any of the user data that they are storing from YouTube or from Gmail or various other Google products. So they actually copy 40 replicas of the data. The fourth one is the metadata tuning. Like, how do you separate metadata servers or disks for high performance from from the other storage stack? How to keep them separate so that you can scale them separately. Okay. Now, let's talk about the applications and the libraries. What are the common libraries that you can use to access these file system? Most commonly used is MPI. MPI IO is used to is for collective IO to minimize the IOPS and metadata overhead. The second is data layout, like how you align the data structures with the file system block sizes, like because it totally depends upon the block size that you have configured in your file system. You have to then when you are writing your code, you have to understand the data structure should be always aligned to the block size of your file system, so that you get best performance from when you run your jobs, your HPC jobs, you get the best performance out. The third is the IO libraries, like I mentioned before, HDF5 or NetCDF. Like you can basically have different chunking or compression or caching parameters. It also helps you to um, leverage deduplication features, where like if you have duplicate data, the file system can actually perform automatic deduplication and save storage for you. And then finally how you have the right behaviors, how you monitor the write behaviors to avoid excessive small writes, like avoid having a lot of very, very small files, or rather like how to batch them up or buffer them for larger operations. So always have a larger batch and avoid very small files. Okay, now based on all of the best practices, now how do we do the monitoring and benchmarking of these file systems? So there are some very well-known open source tools, Linux-based tools that are used to perform the benchmarking. Some of the common ones are IOStat, FIO. LFS is specifically for Lustre file system, and MMFS is specifically for GPFS. But IOStat, FIO, these are generic file system benchmarking tools which can be used on any file system. They are not tied with any specific file system, you can run these benchmarking tools on any of the file systems. Then comes the performance benchmarks, which are like you can use the IOR or IO zone for throughputs and IOPS measurement. Then there is tracing and profiling tools. There is a tool, very popular tool called Darshan, Vampir, HPC toolkit. This helps you to get insights on the IO patterns for at scale. I have shared some of the GitHub links for FIO and how to use it. And for continuous monitoring, you have to use automated scripts, and like you can use Grafana dashboards to watch the performance. And you can, the data that is coming out from these profiling tools, you can push it to something like a time series database, which can keep track of your performance over time. And then Grafana dashboard helps you to visualize those performance metrics or in a nice way. So this particular graph that you're seeing, this shows the IOPS performance and the latency performance for different queue depth levels. Queue depth means like every queue has a certain number of jobs. So you can see each queue has like a various number of jobs, and it has different number of IOPS and latency. Latency is in microseconds, and this is done for specifically for Intel D3 SSD hard drive on IBM M1015 machine. And this was actually ran through FIO profiler. So you can, but you can try any of these tools and different tools for different purposes. So what are the troubleshooting bottlenecks? Because of course, any of these large scale file systems, something can go wrong. So how do you do troubleshooting in these file systems? So it could be, so there are several possibilities which can cause bottlenecks. One could be the metadata server overload. You have basically imbalanced small file operations. That means like you have millions of small files and imbalance operations are happening. It could be a network saturation, that basically you have reached the maximum capacity of your network bandwidth. It could be storage hotspots. That means you have uneven data distribution across OSDs or NSDs. It could be misaligned data access. That is, again, random access patterns for your files. It always results in very poor performance, like increased latency and like bad throughput. Those are like some of the very common possibilities for having a bottleneck in your file system. So one example from real world case study example for this kind of when you have to perform debugging in your HPC cluster. So I have taken a scenario where you have 1,000 node in your HPC cluster, and each running, let's say, a climate simulation. So this is something very common use case for any of the data centers in India where we are running climate simulation for predicting like the weather or predicting the next tsunami or something like that. So you are running various kind of climate simulations. Now, this, let's say it has 1,000 nodes, and you have configured Lustre with 10 or 10 nodes, and each with multiple disks, multiple OSTs. And let's say you have an issue you have found is that saturation you have reached the saturation of metadata server due to millions of small files. Now, how you can take up this problem, and what could be the possible solution? One solution could be, if you remember uh, from what we talked earlier, could be is use large file aggregation. That means that you can tar these small files into larger files as .tar or .hdf file, and use only on on-demand basis. Or the other solution could be increase the MDS resources and like optimize the strike pattern. So this is like one of the very common issues that we find in the HPC environment. Okay, I think I'm moving so towards the end of the presentation. So what are the key takeaways from whatever we have seen in this session so far is one is the parallel file systems like Lustre or GPFS. They are essential for HPC scale data needs. Like otherwise, like you cannot get the throughput of latency performance from your regular file systems. Then proper configuration of striping, networking, and metadata is very critical. Third is data management strategies like tiered approach, lifecycle policies, RBAC policies, data governance policies. Those are very important, and to reduce the cost, secure and have a secure environment, and optimize the input-output throughput as well as latency. And the fourth is ongoing monitoring and performance like benchmarking. These are very important tools. You have to understand the tools to keep tuning your file system to get the most out of your HPC environment. So with this, like these are some of the references that I have used for this presentation. But these are the standard references that you can go through. I have, before we jump into the questions or comments, I have one, I want to share one more thing to show one of the HPC systems so that you can relate what I'm referring to. So, okay. If you can see my screen, I'm sharing a web page from Purdue CMS project. So this is the project that I was referring in the beginning. See, if you see this particular project, it is primarily used for storing all the physics related simulation data. And it has like 6 different computing clusters. They are named as Hammer, Brown, Bell, Hilbert, and Nagishi. These are all professors at Purdue, and like some of them are Nobel Prize winners. Like Nagishi is a Nobel Prize winner in the field of chemistry. And they had all the different computing clusters have been named on their name. So this particular facility, if you can see, we have total of 19 petabytes of data. And let's see about the compute capabilities. Yes. So you can look at the some of the utilization metrics that we have got. we are it is trying to use almost 14,000 cores. So that means 14,000 CPU cores on this cluster, and these are like different clusters, at each like at various clusters, you have different core utilizations. But the peak usage, if you see, we have almost 14,000 cores that you can see in these different cluster. Also, when I want to show one more thing. Yeah. So if you see, these are some of the pictures from the data center, that how these storage systems have been kept. And so these are some of the files server storage class machines where we have configured Hadoop file system on top of these storage machines. And this is this is like one cluster, but there are like 6 different clusters like this. And these are like some of the server machines that I was talking about. This is for the compute part. Okay, yeah. So that is pretty much what I had. We can go for any questions if anyone has any questions.
If you have questions, please ask.
Good evening, sir.
Yes.
Sir, it was a very knowledgeable session actually.
Mhm.
Very different things we learned about. One question I want to ask, like you talked about HPC data management,
Uh-huh.
so in which there was parallel input-output stripping and redundancy was there, under which you talked about the RAID technology. Sir,
Yes.
this RAID is like same as the stripping, or there is any difference between the stripping and in the RAID technology? So I think
Okay,
these
okay.
two
Yeah,
terms,
yeah.
yes.
Please go ahead.
Yes, so just I want to ask about the stripping and redundancy. Like RAID, can we use it for the stripping also, or it is only for the reliability and the redundancy?
So, 2 parts to your question, right? One, you want to understand like what is the difference between RAID and sorry, can you repeat like what is what is you are comparing with the RAID
RAID with the stripping.
with stripping?
Yes.
Okay. Yeah. So see, RAID is primarily used for like disk when you want to configure.
हाँ सर आइए ना बनाते हैं आ रहा है
Um,
आ रहे
uh,
खत्म हो रहा है
RAID is when you want to have a redundant array of independent disks when you want to configure your file system to have multiple physical drives. So you configure like as a single logical unit. Okay, so RAID 0 means like there will be no replicas, but RAID there are different level of RAID like 1, 2, 5, 10. That helps you basically define um, how much redundancy you want to create for your data that you are holding. But stripping refers to the process of dividing the data into the blocks. So both are, uh, you know, uh, different in the sense that RAID is configured at the hardware level itself. Like, when actually you define it at the kernel level, OS level, sorry, at the OS level, when you're configuring your machines, you define the RAID at the kernel level, that what is your redundancy level. But stripping is something that you define at your file system level to to uh, to tell the file system how the dividing of the data should be done into multiple blocks and spreading these blocks into multiple drives in a RAID array. Does that make sense?
Yes, sir. Yes, sir. Thank you, sir. Clear.
Any other questions?
Good evening, sir.
Yes, sir.
Good evening, sir. Sir, am I audible to you?
Yes, I can hear.
Uh, Sir, we have known the Lustre and the Lustre file system and GPFS. Sir, I have heard one other file system also is from Google, the GFS.
Yes.
Sir, could you please give us some small briefing on us, sir, GFS?
Yeah, so Google File System is, as I said, like Lustre and this GPFS. These are just like two popular, but there are many actually. So Google File Systems is a proprietary file system designed and developed by Google. They use it for internally for the Google Cloud storage for storing all your Gmail, for all your Google Photos or like all your Google Drive data. It is basically, one of the key things that I know about GFS is it divides files into like, chunks of into different chunks. I think it has a chunk size of 64 megabytes, and these chunks are stored across multiple chunk servers. They have a concept of chunk servers, and what they do is your data has, I think I mentioned previously in my talk that they tend to create 40 replicas of your data. So like, let's say you store one file in your Google Drive, it will create 40 replicas of that file in the entire in their entire cluster. And the whole point is at no point of time they want to lose your data. So but they also tend to distribute your data across multiple data centers. So how it works is their file system has been configured over multiple geographies. So let's say, I'll give you an example so let's say you have stored a file in Google Drive. The GFS file, when it replicates on the Google file system, right? It creates replicas over, let's say there are 5 data centers in India. It will replicate over all 5, and it also follows the data policies of the geography. Let's say India has a data policy, let's say, of that the data cannot leave the Indian boundaries. Okay, so they cannot store any data in, let's say, US data center or in, let's say, China data center. They cannot store it. But within India, if they have 5 data centers, they will distribute it across the 5 data centers. And depending upon now your location, like let's say you are in Mumbai or you are in Bangalore, depending upon your location, it will, when it retrieves data, it has a sense of data locality. So when you try to retrieve a file from your Google files, from your Google Drive, it always queries from the nearest local replica on the file system.
Yes. So really, sir, it's a really surprise to know that so many replicas of data is created. And
yes.
Thank you, sir. Thank you very much, sir.
Any other question?
Sir, we have created a small quiz for them, which contains only 2 questions. So I can
Sure.
put those questions on the chat, and I just request all of you to attempt these 2 questions. These are based on this session only. One is already punched, another is coming your way. So kindly attempt these 2 quizzes. Actually, sir, what we do is we are trying to make it little gamified, where the first person to answer the give the correct answer. We are giving some reward points to the first 3 correct answers. And,
Okay, very nice.
and then we'll collate it today or maybe tomorrow in the morning. And then we'll declare some winners or see if we can if we can announce it on the validity session. Otherwise, we will be giving them on their WhatsApp groups. And there will be 3 winners, and they will be getting some prizes from LPU, which will be sent to their houses.
Nice.
So to make it little interesting, and the session was really great, and I know first time that there are 40 replicas of whatever data we are feeding. So it's really a nice informative session, and we hope to be in touch, and we'll have more sessions like this, sir, so that all our faculty members and students get benefited from it.
Sure. Thank you.
So we have given questions to the people, and they will do it. And I will invite you in the valedictory sessions as tomorrow. I think it is 7:30 to 8. I'll give the timing on WhatsApp.
Okay, sure.
We can recap the entire program, and our participants can talk and tell about what the key takeaways from this program, session by session, we can do it. So I'll give you
Sure.
the timing so that, and request you to join us. It's just for half an hour.
Sure.
So I think give a thumbs up if you are done, and we can leave. I'll ask if you are done with that. One question was there, sir. I just also want to ask, there was a question that what is the difference between functions of RAID 6, RAID 10 and RAID 7? It was asked by Zakir Hussain. What is the special functionality in RAID 6 and RAID 10 as compared to RAID 7?
I see. See, all these different configurations, like RAID 6 or 10, right? These are like different levels of um, like how you define your distributed parity. So 6, 10, all these numbers, these are like definition, the configuration number for your parity, and the how redundant you want to or like how fault tolerant you want to keep. Like RAID 6 can withstand with like there are different levels. Like RAID 6, it can withstand with failure of up to 2 disks without any data loss and making it very highly reliable. Whereas like RAID 10, which is like a combination of 1 plus 0, it combines the features of RAID 1 as well as the RAID 0. So RAID 1 is typically mirroring. So whatever you have data you have in one disk, it is mirrored, and RAID 0 is stripping. So stripping uh, like it requires like minimum 4 disks, I think. So it requires 4 disks and provides both high performance and fault tolerance because it is a combination of mirroring and striping.
Great. So Jackie, sir, I think your answer, you got the answer of your question, Jackie, sir. If you can answer. Now, yeah, Jackie says thank you. Sir, we have a test tomorrow for which you have sent the questions also. So we request you to give some reading material. You can send on WhatsApp so that we can post it on the group so that our participants can have some material for the examination tomorrow, what we are having at about 7 o'clock.
Okay, sir.
So thank you very much, everyone. Thank you, sir. Have a great time.
Yeah.
And we will meet once again. And I wish everyone should be coming tomorrow, sir, especially an invitation to you. So we will see you.
Sure.
I will send you the timings, etc., and the link also.
Sure. Thank you so much
Good.
for patiently listening the whole session. Thank you very much.
Thanks a lot, everyone. Anyone having any question as far as conduct is concerned, please let me know. I have posted about 3 to 4 PPTs on the group. You can go through those PPTs. Tomorrow we have a test. And rest of the PPTs are coming as I've requested all the resource persons to share their content. Please give your feedbacks. Please give your feedbacks. That is very important.